Hi, welcome to my talk about OpenFaaS. I'm Alex, I'm from inovex, and I want to talk about serverless. First of all, who am I? I'm DevOps engineer at inovex. I'm mainly involved in this computer thing somewhere in between bare metal and serverless. inovex itself, we are IT service providers and try to give our customers methods, technology, and cultural awareness for our recent times. One aspect of this is the uh, technology, in which we try to evaluate new technologies and new trends. And one trend is the serverless movement, which is obviously around since 2014 with AWS Lambda. But in recent times, we've seen that there is a lot of movement into serverless technologies, serverless stuff, and function as a service. So I want to talk about what is serverless. I did it. I did copy definition from Wikipedia, which states that serverless computing is a cloud computing execution model in which the cloud provider runs the server. Which means I do not touch any infrastructure as code. I do not need any virtual machines or EC2 instances or maybe some bare metal systems. I just have my function and drop it to the cloud provider. So as you've seen in my title slide, I want to talk about serverless self-hosted. Um, some kind of strange thing because serverless self-hosted. My definition states that serverless is an execution model in which the cloud provider runs the server. So why do I want to talk about serverless and self-hosted? Mm, Think about you probably, or maybe you got a data center that can be used to leverage your serverless movement. Maybe this cloud thing is considered evil at your company. Um, you want to try some local mocking and try to check if your ideas behind your serverless function is working. You need a simple demo environment to go to your CTO or maybe to your customer and show, hey, this is your application made serverless. This is a proof of concept. Look at it. You might want to have a server self-hosted environment for your CI/CD pipeline, or as always in tech, because it's possible, we want to try to host it for ourselves. Okay, so which options are there around? What can we do? Uh, if you Google serverless and self-hosted, these are the three main competitors. You will find Knative and Kubeless and OpenFaaS. Both of them, all three of them depends on a Kubernetes backend in which they schedule the functions. Knative and Kubeless and OpenFaaS. But I want to talk about OpenFaaS. As already stated, OpenFaaS leverages Kubernetes to run your function as container. I tried to introduce this talk with serverless made simple. And one does not simply deploy Kubernetes. Is there another option? Yeah, it is. And this is some kind of demo environment I will show you in a few minutes. There is some part of the OpenFaaS community project that is called FastD. FastD is a simple Go binary that do not leverage Kubernetes, but uses ContainerD as runtime for functions. Think about a smaller installation without the Kubernetes backend, but with all the stuff that OpenFaaS provides you with CLI and all the same workflow and stuff, but not with Kubernetes as backend, but with containerd. There is one thing in there that might attract your intention, your focus. FastD uses containerd. This means all your functions will end up as containers. Maybe AWS Lambda does not run containers, we do not know, but these server self-hosted technologies I mentioned earlier, meaning kubeless, Knative, and OpenFaaS, they use containers as execution model for your function. So even if you start now with FASD as a simple setup to get an environment bootstrapped quickly, you can later switch to another of these server self-hosted options without changing the execution model. So every function you write ends up as container. And that's enough as introduction. I will go to a demo. So I provided on our inovex internal OpenStack Cloud demo environment, and I will show you the web UI. I will show you a little bit about FastCli and what is there to get started, meaning the setup. And I can show you a little startup, how fast, with the startup time, how fast OpenFaaS or this FASD setup is. I'm switching over to another tab. As you see, there is an URL. I made this public available via this thing called internet. And first thing about OpenFaaS or FASD, there is always a basic authentication switched on. So there is no way you can expose these admin UI to the internet without having the basic authentication. So I've already copied my credentials in there, and now you see the OpenFaaS UI. It's not pretty. It's functional. On the left, you see I've already played a little bit with my demo environment in the preparation of this talk. I deployed two functions, one called NodeInfo, the other called Inception. You can see in the middle of my screen the button to deploy a new function. But first, look at the functions that are in there. Let's go to NodeInfo. NodeInfo is just a simple function that displays the stats of the execution environment, meaning how much CPU and how much memory is there. You see, this function is ready, meaning the Docker image is pulled, or the container image is pulled, and can be executed. You've seen there is one replica. Replica means there is one container instance, a container waiting for to be executed. If you start with OpenFaaS, with Kubernetes backend, there is the option to have more replicas with one host that I'm having in my demo environment. There's no option to have more replicas because it's only one host. And you've seen I've already invoked this function 7 times. You see the base image, the image used for this function. Within these web UI, I can now click on invoke and see the results of my HTTP call against the endpoint. You see response status 200, and as mentioned, the information about the runtime. You see it sits on Linux server and the memory and CPU count. You all again can copy the URL and try this for yourself. I'm switching to a new tab, a new incognito tab, and show you something. So I can invoke this via browser. It's again just an HTTP call. The reason why I switched to the incognito tab is to have a new environment and to show you your functions are public. The administration dashboard I've shown you earlier is protected with HTTP basic authentication. The functions you drop in your OpenFaaS or FASD environment are public. So keep that in mind if you want to play around with it. Now, if I'm going to reload these NodeInfo function I've already deployed, you will see nine invocations. One from me now with the dashboard and one via browser. Let's say we want to deploy a new function. Click on deploy new function, and now we get a catalog that is preceded from the OpenFaaS project. This is just a JSON file that can be overwritten by yourself to have your internal functions or your self-written functions. But if you do not provide any JSON, there are some functions you can select from and try them for yourself. So another one might be just click on lookup and deploy this function. You should now see that the dashboard is reloading, and you see there is another function lookup. In the background, maybe you've seen it very short. There is the status not ready. My container D is pulling the image, and try to make this function ready. And now it's ready. I can now invoke this function, and you see success. I do not support. I do not send any more information, so it's okay. It's 200. Let's switch over to the CLI. You should now see my screen. I already logged in via SSH to the instance. And now I will show you the FaaS CLI. This is also already installed, and I can use the FaaS CLI to log in, to list the functions, but you can see again, administrative access is restricted. I need to authenticate against the my FaaSD. This can be done via a secret that is generated while starting. If it's not present, if with FaaSD starts and there is no secret present, he creates one and drops it in the file system. And now I can pipe this just to my FaaSD FaaS CLI login, and now I'm authenticated. Now I can do the list stuff again. You see the three functions I've shown you via the dashboard with all the same information. It's again invocation and replica. So FaaS CLI can do a lot more. FaaS CLI can also deploy or look into the store. So let's look into the store, FaaS CLI store list, and now you will see the same amount of information you seen in the admin dashboard via command line. And now you can do store deploy, and then just copy the hey function. And now what's happening? Again, containerd is pulling the image, and you now have to wait until containerd is ready and say, okay, deployed, and the function is there. That's again the same set of features than in the administration. UI just means you can automate all that stuff, maybe in your CI/CD pipeline, create a new function, trigger the function, delete the function, and all the stuff. I wanted to show you something about the setup. As stated, there is containerd running. You now see that my containerd, my demo environment, is running since over 1 month. And we can look at the container that are running via CTR CLI. I hope this works. So CTR and SLS just list the namespaces containerd has created for me, and you see there's default namespace and there's the OpenFaaS namespace. I can now select. Now I do a container list, and now I did the run command. Sorry. There's a namespace. Yeah, I had a typo in there. Now you see the running containers. You see the function name is matched into the container name. So you can you have one container called hey. You see the Docker, the image called fetched from Docker.io, and you see the runtime. It's run CS container runtime. That's all. There is a, I wanted also to show the start deployment, how fast fastd is. There is a bash script I just wrote that is starting fastd if it's not started, and just have to look the deploy the figlet function. We have to make sure the function is not there, otherwise the demo is not it's not showing the real startup time. So again, we look at fastclear list. Check, there is no function called figlet. Now I'm running this bash script and show you. This is only to show how fast a cold start with complete deployment of a new function and an HTTP call to this function is, you've seen probably 5 seconds or something. And now to show you that the function is there, there is now a new function called figlet. We just deployed. So to clean up our mess, I go back to the dashboard. You now seen the dashboard also has reloaded, and there are a lot of new functions we just deployed. And now we are just doing deletion. We're just cleaning after ourselves. So this is the cleaning process via the dashboard. Again, you can use fastclear. You see the remove option here, remove, and then now again, just look at the functions, what is there. We're removing the function, and the functions are gone. Now the situation on my demo environment is I've already pulled the image from the Docker IO registry, but there is no container that is called figlet. So just to show you, where is my container? The container is gone. This means if I now deploy the figlet function again, the starting time will be better because the pulling is already done. So just keep that in mind. Back to my presentation, because that's all I wanted you to show. Got some more slides to wrap it up. Is this now a good thing or is it a bad thing? It depends on your expectations. It's pretty simple. The setup itself for my fastd instance, it's just spawn a cloud instance or any instance, VM, just started a new HP server or something, started via VM, started an EC2 instance or start some instance, install ContainerD and pull a Go binary. That's called fastd, and that's all. Start it and you can play around with serverless. So it's pretty simple to kickstart the features, to kickstart the environment. On the other hand, it's simple, meaning the feature set is limited. Authentication is only done via basic out. And if you want to have more advanced authentication methods, you need some load balancing or reverse proxy in front of your fastd. It's fast, meaning fastd with deployment of function is approximately 5 seconds. So you can think of fastd as part of a CI/CD pipeline that does not slow down you. If you want to start a complete demo environment and check something, I've written Terraform wrapper around it. It took around 60 seconds. Most time is just start the instance. So again, this can be part of a CI/CD pipeline without significant time loss. One other aspect, meaning simple, it's fastd, it's not cool for production. It's just a teaser. How can serverless in a self-hosted environment looks like? How can it feel like? As stated earlier, everything you do with fastclear against a fastd, you can do against an OpenFaaS installation that is powered by Kubernetes backend. So with Kubernetes backend, with a production-grade Kubernetes cluster, it's a totally new game. Your workflows might be the same, but the production grade might be bigger. And again, I stated it, it's unsafe. Authentication is just a basic authentication. It's not pretty much sophisticated. You can see the slide. There are some links pointing and give you more to read. Yeah, and that's all. Thanks for listening to me. If you want to play around with serverless and do not want to play around with AWS Lambda or giving the cloud providers so much money for each function call, consider playing with OpenFaaS, maybe with FastD, and just try it for yourself. That's it. Bye. Have a good time.